Alright, here we go. We are going to today find the perimeter and area for regular polygons. First question. What does regular mean? All the sides and all the angles are the same. Let me ask you this another way. What is the only regular quadrilateral?
Square.
Square is regular quadrilateral. What we're going to deal with here is we're going to deal with regular polygons. It's going to have a bunch of sides. Could have 50 sides. Whatever.
I've never heard the French fry.
All right.
Hot dog.
Compass. Measure 4 inches. Compass. Measure 4 inches. Put that circle towards the top of your paper. A nice 4-inch circle. Do not allow your compass to slip.
No slippage.
Slippage is bad.
Wait, should this take up like almost the whole paper?
Yeah, it should.
Wait, should take up almost the whole
Yeah, it should. 4 inches. Put my compass point anywhere. I'm going to choose right here. And I'm going to go around the circle 6 times. 1, 2, 3, 4, 5. The cool part about this construction is if you did it right, that spot you originally put your compass in right there should be the spot where your last arc hits. After you go around 6 times, you are going to create the regular hexagon that is formed from those arcs. So I'm going to go around 6 times for a regular hexagon. Pause. Every time we need to find n. N is the number of sides. On this one, that is what?
8. 6.
What? 6. There's 6 sides. Find n, which is number of sides. And in this case is 6. Number 2, we are going to find the interior angles of the polygon. We will start with the sum of the interior angles. Okay? A while back we had a formula for this, and I'm just going to give you the formula. It wasn't one that we worked with a ton, but we did have a formula. It was n minus 2 times 180 degrees. That formula got us to how many degrees there are in a polygon. So, all you gotta do is take the 6, you plug it in for the n, 6 minus 2 times 180, and you can get how many degrees there are total in that hexagon. Can somebody do that on their calculator for me? 6 minus 2 times 180?
720.
What's that? Yeah, 720. Okay. 720 degrees. Here's what we just found. This, plus this, plus this, plus this, plus this, plus this. All of those angles, they add up to 720. How would I find each angle?
Wait, why would you take your minus 2 again?
By 6. That's the formula. Number 3, we're going to find each interior angle. Each interior angle is that answer right there, or n minus 2 times 180, whatever you get out of that, divided by the number of sides. In this case, that's 720 degrees divided by the number of sides is 6. 720 divided by 6 is?
108.
What's that?
108.
108? I don't think so.
No.
120.
120 degrees, isn't it?
Yep.
Better be 120, because I know these angles are all 120. 120. These angles are all 120 degrees. What I would like you to do is see how close you were on your construction by taking your protractor, putting it on right there, and seeing, hey, did I get 120 degrees like I'm supposed to? Do that now. Possibly pinwheeled it out. It's all those angles formed if we pinwheel it out. That, 2, 3, 4, 5, 6 of those angles. Anybody remember the degrees, no matter what the polygon, if it was the exterior angles?
180, right?
What's that?
180?
You were close, it's that times 2. Some of the exteriors is always 360 degrees. Those angles right there always add up to 360, no matter what kind of polygon it is. How would I find each one? Divide by 6. So step number 5 here, each exterior is always the formula, 360 divided by 6. In this case, it's 60 degrees. 360 over 6 is 60 degrees, and I'm 100% sure I got that right. Wow.
Plus 120 plus, yeah, 120, 60 equals 180.
Add to 180. 120 and 60 are a linear pair, they should add to 180. We're going to go through and we're going to find the area of this polygon. So the first thing we need to do is we need to talk about how. How in the world, looking at that green thing, how in the world am I going to find the area, well I'm going to probably get the perimeter end area of that polygon. Any ideas? Yeah, Alex? Lots of triangles in there. By the way, if you could divide it up into a bunch of triangles that are all the same, how many triangles, just without me even doing anything, how many triangles do you see up here that are all the same? 6. I see 6. I see one here. I see a bunch of pieces of pizza. You know what? If I could find one of those pieces of pizza and multiply by 6 on this one, I could get the area. Now, other ways of doing it. I could divide it like that and make it into 2 trapezoids. I could find each trapezoid. I could go like this. I could have a rectangle and 2 triangles. I could find those. But by far the easiest way of doing this is, and I can't see it because I erased it, I'm going to put a little dot where that center was, and I'm going to make a triangle. There's my triangle. So I can find the area of that triangle. First thing is first, I want you to, with your ruler, measure from finger to finger. With your ruler right now. From finger to finger, measure. Which finger?
Not like 10
Inches.
4.
How big?
4.
4. Well, yeah, it is. I used my, and I made 4. I made a 4-inch circle. So it makes sense that from here to here is 4 inches. That makes sense to me.
Wow.
60.
Yeah.
60 degrees. If I'm going to find the area of a hexagon, I'm going to need the height. Here's my height. Right there. I'm going to need the height. I'm going to need the base. I'm going to put an H here. I'm going to put a little a here. And little a there is going to help me find the base right there. Those are the things I'm going to need to find in order to figure out what the area of this polygon is. Now, let's find the height first of all. I want to find the height right here. Pretty easy to use a 30, 60, 90 triangle on this problem. This is the only one that uses the 30, 60, 90, so even though I could, I'm going to go through SOHCAHTOA. Let's just see if we can do this real quick. A, how big?
2.
2. 30, 60, 90. Across from the 90 is 2x. X is 2. This is 2. How tall is it really?
2, 3.
2 root 3. This is 2. This is 2 radical 3. With the 30, 60, 90, I can do that. I'm going to use SOHCAHTOA. Here we go. Let's find A. Find the A value. Here we go. I want this. What?
Wow.
Adjacent. Adjacent.
Hypotenuse.
Adjacent hypotenuse is?
Cosine.
60 degrees. Adjacent hypotenuse is cosine. So the cosine of 60 is equal to adjacent side A, hypotenuse forward. Right now in your calculators, find A. Go. Pause. 60 times 4 in your calculator, you should get 2. Same value we said we're in the 30, 60, 90 triangle. So the A value is 2. 7, let's find the H. Here we go. What's that?
Should we just do opposite? Hypotenuse.
Can we
Opposite hypotenuse. We're going to use sine. Can't we what?
can we just do
Pythagorean theorem.
Yeah.
Absolutely.
why don't we do that?
Because I show straight. Use Pythagorean theorem if you want. It still works. Same deal. Different way of getting there. Good idea. All right. I'm going to use sine of 60 is equal to opposite. It's so. We're finding where this was CAH on that one. This one we're using SOH. Sine opposite over hypotenuse. Opposite is H. Hypotenuse is 4. Do that on your calculator and find your H value. 3.4 something, right?
4.46.
4.6. Here's the cool part because we're doing it this way. You should be able to take your ruler, you should be able to run it right down the height, and you should get just under 3.5 inches if you did it right. Check it with your ruler now. Is it like almost 5? Almost 3.5 inches, right? Tells me we're doing it right. So I got an A value. An A value here, that's 2. I got a height value here, that's 3.46. We are ready to finish the problem. We have easy math now to finish the problem. 8. Let's find the perimeter.
16, 12.
Not 12. You're close. You made a common error, but it's not 12.
Nope.
It's 24. That's 2. That's 4. I gotta use that 4. 4, 4, 4, 4, 4, 4.
Oh, I was doing the triangle.
24, yeah, it's 4 times the length of one side times the number of sides times 6. In this case, the perimeter is 24 inches. 9, let's find the area. And here's my formula for the area of all these polygons. People, what you're going to do is you're going to find the area of one triangle every time.
Multiply by
how many triangles there are. So I literally write that. Area of one triangle times the number of triangles times n times the number of sides. The number of triangles is always the same as the number of sides.
Their
In this
bases.
case, there's 6 sides, it would be 6 triangles. All right, here we go. Area of one triangle, I take 1/2 the base times the height times the end. 1/2. All right, what goes in for B? 4. What goes in for height? 3.46. There are 6 sides. Do the math on your calculator. Go. Go. Do I have a consensus on area? 41.52? Sounds like that's what we're getting. 41.52, and that would be in inches, because we drew our circle 4 inches. Inches squared. We have a 41.52 square inch polygon. In this case, hexagon. And that's it. Those steps are what we're going to use for all the polygons.
I won't zoom in. I was trying to zoom in on your face.
Don't do that.